So let's discuss about containers today. So containers being a very great topic and nowadays because it has just started few years back and then it has built into the enterprise market. So like hell. But the one thing is, it's been open source, so it has been widely used for a lot of enterprise customers and also by our private dogs or schools or universities. So let's go and take a look why we actually require containers and how we use containers and what containers do, and then we will discuss about the future of it. So why containers? Okay, so before going to this, let me take you to the small diagram in here. So here you can see, so this is virtual machine, this is an architecture of a virtual machine, and this is an architecture of a container. Okay, so how exactly this their work is like the virtual machines will be having server, and then the like server is sort of a laptop. Okay, on top of your laptop you just install a host OS. It's not on the bare metal, you just host Windows, Linux, or any Linux distributions like Ubuntu or any other thing. And on top of that you have something called as hypervisor or Hyper-V. Basically, like Hyper-V is like it's sort of one particular version from Microsoft Windows. Also they have their own version of Hyper-V they call, and then there is another virtualization technology which is called as VMware. And on top of this, like one need to install this Hyper-V or VMware, and then they can install a guest OS on top of it. So this guest OS can be Windows and can be Linux, can be Mac OS or any other particular flavor irrespective of what exactly the host OS is. So that was very good because anyone can run any sort of applications. So applications which can only be run on Windows can be run on a Linux host OS because the guest OS can be Windows, and it's vice versa with it also. The application which can be run on Linux can be run on a guest OS. So everything was good, but again you can see there are a lot of OSs are involved here. So sometimes for enterprise versions there are licensing as well if you use multiple versions of Windows. And then what everything life was good until unless the containers was introduced. So what containers helped in is like it has abstracted of using guest OSs. It just started sitting on the host OS, and it got all the binaries, libraries, and every dependencies underneath the particular container or any particular Docker engine which runs these containers. It just has a single package with application and its dependencies, and it was all good to go. It didn't had any dependency of guest OS, whether it's Windows or Linux, which it needs to run. Okay, so that was one good thing when container came. But what exactly and why we require containers is this points can explain. Since you can run software so reliably, which was never been done with virtual machines or any other particular concepts. So one particular example I would call up here is like if you want to run an applications in your staging, in your QA, prod, or test, and the underlying the software should which is running on an underlying infra should always be the same. It should always have the dependencies, binaries, the dependency software like Apache or .NET runtime. Everything should be of similar version. Or if they are, if you're moving or running on different systems, because where it will help is like if a developer is developing a certain code using a certain dependencies or a version of dependencies, or running his application on Apache for testing it, he will have the seamless experience of the same thing. The same experience will be there even if it goes for the prod, because in containers it will induce or in it will embed all those binaries or all the dependent libraries which he was using in QA or test or in his dev machine all through the prod. Okay, so that's a great thing. So it actually made software more reliable than it was. And then like it's sort of open source. It's open source, so basically you can use it, and unlimited instances you can just run it and you don't get a license charged on it. So one particular enterprise offering which actually kicked in so much in the market is Kubernetes, and we will be going a lot of concepts like this for Kubernetes in this particular series of playlist. And then the security, also one particular aspect which I would talk about is, sign in container images, like developers or persons who publish the images, container images, can sign in. So it would ensure, like, they have trusted images always running, the trusted images always running in the prod or any particular environment. So that was one thing, few of the things which I can talk about why we require containers and how we actually use it in our day-to-day life. It's like you just have a container, consists of all of your runtime in it, and then so the runtime, what it would have, the runtime would have, it's a runtime would have an app, an application, and it would have the dependencies, the dependence libraries, and it can have their own particular binaries on which the dependence libraries depend upon, and they can have configuration files which are needed to run it. It's just these particular files they just require, and we can just run it on any bare metal, irrespective of whatever OS we can opt for. So, what exactly containers do, and to where exactly it makes its impact? So, the impact where it the where it makes is, like, it occupies very less size. So when it takes a very less size, you can actually host a few more, 10 more services instead of just two more services which you would have hosted in your virtual machine, or even one or two applications in a bare metal machine. And it's also good because the uptime is so quick, because there is very less boot time, because for a machine to boot up it would take minutes, and similarly with the virtual machines, but with the containers it's just few seconds. So your applications is always up and running, even if your application is killed by any other process, then you can actually spin your pod, and evenly, like, these all pod spinning, everything is managed by Kubernetes, so that's even more better because someone else is there to make your applications always on when you are not there. So, and also another thing is the approach towards modularity. Since all the world is going towards microservices, and using the containers concept, you can actually split your particular code or modularize your code, which was never been done earlier. So what you can do is, like, take an example, like you have a three-tiered application. You can host your front end in one particular application, a container, in an image, and you can host your middle tier somewhere, and you can host your data layer or your database is running on another particular container. So you can all make communication with among them, but you can independently scale them, you can independently monitor them, and you can independently set up access control to each other. Okay, so that's one good thing which is I would like to point out, because the more granularity or modularity you are able to make, and you could be able to develop microservices, or you can decouple, or you can break your existing services into very smaller chunks, so that if even if one particular API is affected, it won't completely disrupt your product. So that's one thing. And but what do you say, like, will this particular shift of mindset, where people had moved from virtual machine to uh, microservices, or so-called as containers, will it make sense for in future? I would say no, because the virtual machines, the level of isolations or the security which virtual machines had, like how it would be actually, can stop an interaction of a user entering from an application running from an guest OS, can't actually directly interact with host OS because there is an Hyper-V. But now, like, if you're running a pod, the pod from an image, if you're if you are into the pod, you are able to log into the pod, then you have a particular access to host OS or some particular component of host OS, or you can have access to other applications as well. So that's level of insecurity which is there with containers, but not with the virtual machines. But again, the containers are getting mature, and the vendors, specifically the Kubernetes community, and they are actually strengthening this particular access control by implementing something called as pod network security, and pod network security, pod security policies, and network security policies, and isolation of cross namespace communication. And there are other, lot of different services which are coming across, features which are coming across to strengthen the container security. So hopefully that would make the containers more secure, but till that time virtual machines will always be a little bit option of securing your application from the others if you're hosting in a shared environment. With this, I hope you would have got a little gist about containers, and like this topic, we will be going through in this particular series, which would be just concentrating upon why, how, and what